Jai Hind everyone. So the topic we are going to take today is capacitances. Let me write down capacitances. So let me tell you that this topic is in IB curriculum chapter 11 HL, that is high level. Okay, so let's get started with this topic. What do you mean by a capacitor first thing, and then capacitance? So let me write down capacitor. Capacitor is such a device which is used to hold the charge. Capacitor is such a device which is used to hold the charge. First point is this. Second point, capacitance. Like we have resistor and resistance, in the similar way we are having capacitor and capacitance. Let me explain again. Like we have resistor and resistance, in the similar way we are having capacitor and capacitance. So resistor was a device, resistance is its property. In the similar way, capacitor is a device and capacitance is the property. So it is the property, or it is the ability to hold the charge. It is the ability of the device to hold the charge. Let me write down. It is the ability of a device to hold the charge. Okay, so let us take an example. Suppose we are having a conductor. Suppose we are having a closed conductor, spherical conductor. Okay, a hollow spherical conductor. Let me write down hollow spherical conductor. Conductor. So now we are going to give some positive charges to the conductor. Whenever we used to give positive charges to the conductor, the charges will appear on the surface of the conductor. Like this, and the charges will redistribute itself and making the surface an equipotential surface, because a sphere is a symmetric surface. So likewise, when we are giving the positive charge to a hollow closed conductor or a hollow spherical conductor, the potential of the conductor will go on increasing. Hence, we can say when we are providing the charge, the potential of the conductor is go on increasing. This means that potential depends upon charge. Likewise, whenever we will be keep on increasing the charge on the conductor, the potential of the conductor will keep on increasing. Hence, V is directly proportional to Q. As I have highlighted the fact. Okay, so on solving, we will be getting that V is equals to, or I must say that CV is equals to Q. The constant will come in that side which is a dependent quantity. So we used to keep dependent quantity on the left side and independent quantity on the right side. Dependent quantity on the left side and independent quantity on the right side. So CV is equals to Q. The constant is C. Here the constant is C, which has been kept to remove the proportionality sign. To remove the proportionality sign, we have introduced C over here. Hence, we can say that C is equals to Q by V. C is equals to Q by V. We must write down it over here that capacitance is equals to charge upon potential. Charge upon potential. Okay, so this is the formula we are having. But I must tell you that the capacitance of the capacitor will not be dependent upon charge and potential. However, from the formula we can see that capacitance is equals to charge upon potential, or we can say potential difference. We can say potential or potential difference, both we can say. So let me write down, it may be charge upon potential difference as well. Potential difference. So don't get confused that it is only potential, it may be potential difference. So capacitance equals to charge upon potential difference. But it is not true that capacitance will depend upon charge and potential difference. So we must write down that capacitance is independent of charge and potential difference. Hopefully it is clear to each one of you. Now let me discuss that on what factors the capacitance of a capacitor depends. On what factors the capacitance of a capacitor depends. So the capacitance of a capacitor depends on first shape and size of conductor. Nature of medium. Okay, and the last one is presence of other conductor nearby. So the first point is shape and size of conductor, nature of medium, and presence of other conductor nearby. So you must think or you might be thinking that is it dependent on the nature of the material or not? So I must clear you that capacitance of a capacitor remains independent of the nature of the material. So I'm writing it over here that capacitance of a capacitor remains independent of nature of material as well. Okay, so suppose we are having the earth. And if someone asks you that what is the capacitance of the earth, because earth used to store the charges, then what is the capacitance of the earth? So what is the formula? C is equals to Q upon V. So what is the formula of V? Let me write down. The formula of V is K Q upon R. This is the formula of V. Keeping the formula in the previous equation, this is your equation number 1. This is your equation number 2. So C will be equals to Q. If I use capital Q over here, it will remain same. Okay, it will remain same. So it will be KQ upon R, isn't it? The value of K, we have kept it over here. kq upon r. This q and this q will get cancelled out. So we will be left with C is equals to R upon K. So R upon the value of K is 1 upon 4 pi epsilon naught. So the value will be 4 pi epsilon naught R is equals to C. On solving, we do know the value of pi, that is 3.142. The value of epsilon naught is 8.85 into 10 to the power minus 12 into radius of the earth, that is 6.4 into 10 to the power 6. On solving the total value, we will be getting C is equals to 711 microfarad. So this mu is your micro. This mu is your micro, which stands for 10 to the power minus 6. Which stands for 10 to the power minus 6. Hence we can say that the capacitance of the capacitor which we are considering as the earth is 711 microfarad. So the biggest capacitor we can have on earth, that is the earth itself, is 711 microfarad. So we can have different sets of capacitors available in the market, but the biggest capacitor we are having, that is 711 microfarad, which we are considering as the earth. Now all the capacitors which we used to get in the market, the shape and size of these capacitors will be definitely lesser or smaller than the size of the earth. Definitely it will be smaller than the size of the earth. Okay, so the types of capacitor, let me write down. Types of capacitor. Types of capacitor. So the first one is your parallel plate capacitor. Parallel plate capacitor. The second one is your cylindrical capacitor. And the third one is your spherical capacitor. Spherical capacitor. If I go for the diagram for spherical capacitor, so let me give a small heading as spherical capacitor. Spherical capacitor. Let me tell you one more thing that I forgot to say, that Farad. Farad is the SI unit of capacitor. Okay, again I am saying Farad is the SI unit of capacitance. Farad is the SI unit of capacitance. So, I must write it over here. Let me write it, that Farad, F-A-R-A-D, Farad is the SI unit of capacitance. Since Farad is a very large unit, so we used to specify capacitors in terms of microfarad, millifarad, nanofarad, picofarad. So these are some smaller terms with the help of which we used to define the capacitance of a capacitor. So I do hope that 1 microfarad, if it is written, then you know that micro means 10 to the power minus 3 farad. This is millifarad, M means milli. For micro we will be having 1 into 10 to the power minus 6 farad. 1 nanofarad means 1 into 10 to the power minus 9 farad. 1 picofarad means 1 into 10 to the power minus 12 farad. So this is how we specify the micro, milli, nano and pico. Okay, over to the next slide, that is the spherical capacitor. So for the spherical capacitor we are having a certain diagram. So let me draw this diagram in the next slide. So the diagram will be as such. So let us have two spherical conductors over here. Now the positive charge is being given to the inner face of this conductor. Positive charge is being given to the inner face of this conductor. It will be seen like this. It will be seen like this. Okay, hopefully it is clear. Due to the positive charge, negative charge will get induced over here. Negative charge will get induced over here. Now you might ask that, sir, what lies in this place? What lies in this place in between these positive and negative charges? So this is your dielectric. Let me write down. This is your dielectric. So what do you mean by dielectric? Dielectric is such a medium which will not conduct by itself, but it will help to induce the charges. Let me repeat again. Dielectric is such a medium which will not conduct in the presence of electric field, or it will not conduct the current, but it will help in the induction of charges. What do you mean by induction of charges? If the positive charges appear on one face, then the negative charge will appear on the other face. Or vice versa, if the negative charges is appearing on one face, then the positive charges will appear on the other face. So this is the work of dielectric medium. Okay, so the space between this is filled with a dielectric medium, so it will not be conducting by itself. However, it will help in the induction of charges. So what will be the value of such a capacitor if we are having a spherical capacitor? So the value of a spherical capacitor is 4 pi epsilon naught AB upon B minus A. So what is your B and what is your A? Let me mark in the diagram. This is your A, okay? The inner radius is A, and this one is your B. This one is your B. Hopefully it is pretty much visible. So this is your A, radius of the inner circle, and this is your B, that the radius of the outer circle. So the formula stands 4 pi epsilon naught AB upon B minus A. So this is the value of a spherical capacitor. So hopefully you have understood till this topic. This is Er.Shreya signing off. Thank you.